everyone, welcome to Dyness Tech Lab. Today, we'll demonstrate how to perform a hybrid parallel connection using two PowerBrick SC, one PowerBrick and a Solis inverter. This guide walks you through the standard procedure for mixing old and new PowerBrick, 280 amp-hours and 314 amp-hours battery models. This video is designed to guide operators through the hybrid parallel setup of PowerBrick battery system. The products involved include older models in the 280 amp-hour series PowerBrick Pro, new models in the 314 amp-hour series PowerBrick SC, PowerBrick Plus, PowerBrick Max. When batteries with different capacities or aging levels are connected in parallel, differences in internal resistance may cause uneven current distribution during charge and discharge. This can lead to overcharging or overdischarging of certain batteries, reducing lifespan and potentially creating safety risks. This procedure should only be performed when necessary and with full understanding of the risks. Before proceeding, make sure the old and the new battery BMS units can communicate and operate properly together. Tools: prepare the following: DC positive cables, DC negative cables, communication cables. Make sure they are compatible with the battery and inverter interfaces. Environment and system check. Before starting, confirm the following. 2.2 Environment and system check. First, all battery units are powered off. Second, check and record the SOC of each battery. The difference should ideally be within 10%. If not, balance them through charging or discharging. Third, ensure the inverter supports multi-BMS communication and is properly configured. Finally, confirm the installation environment is dry, well ventilated, and away from flammable materials. Step 1. Power off. Disconnect the inverter from the grid and PV system to ensure it is fully powered off. Then, turn off all PowerBrick units using the on-off switches. Step 2. Parallel connection. Now proceed with the parallel connection. First, connect all battery positive terminals together, positive to positive. Second, connect all battery negative terminals together, negative to negative. Third, connect the combined positive and negative bus bars to the inverter's DC input terminals. When connecting the communication cable, the DIP switch on slave 1 should be set to 4 zeros, the DIP switch on slave 2 should be set to 4 zeros, and the DIP switch on the master is determined by the inverter. Finally, double-check all connections to ensure they are secure, correctly polarized, and free of short-circuit risks. Key notes: make sure cable specifications meet the maximum current requirements. Use a cross-connection method to balance resistance across all battery paths. For mixed capacities, place lower capacity, older batteries closer to the inverter to reduce impedance differences. Step 3. Power on. Turn on each battery one by one. Check the battery displays to confirm normal startup with no alarms. Then switch on the inverter DC side and start the inverter. Finally, check the inverter display to confirm that communication with each battery has been established. 4.1 SOC check. Test objective. Verify whether the SOC displayed on the inverter is the average of the SOCs of each battery. 1. Record the SOC of each battery and calculate the average value. 2. Compare this with the SOC displayed on the inverter. 3. Under normal conditions, they should be close. Normal condition. The SOC displayed by the inverter should be close to the average of the individual battery SOCs. After the BMS master aggregates the information from the slave units, it outputs the total SOC of the parallel battery system. Exception handling. If the inverter's SOC deviates by more than 5% from the arithmetic mean of the individual battery cells, there may be a communication error or data desynchronization. Please check the BMS configuration and communication connections. Let's look at this example to better understand it. The inverter displays an SOC of X. where X equals 80%, battery SOC values are a 1 equals 80%, a 2 equals 76%, and B equals 70%. The average battery SOC is Y calculated as Y equals open parenthesis 80% plus 76% plus 70% close parenthesis divided by 3. If the deviation between inverter SOC and average battery SOC is within 5%, the system is normal. Check both the inverter display and battery panels for any alarms or fault messages. Focus on fault codes, alarm icons. Check the inverter display for any red fault codes or alarm icons. Warning indicators. Check whether any fault indicator lights are illuminated on the battery panels. Communication status. Check the BMS communication status to confirm that communication between the master and slave units is normal. Under normal operation, no faults should be present. If any issue occurs, record the fault code and troubleshoot according to the manual or contact technical support if needed.
1. Mixing batteries in parallel is generally not recommended for long-term use. However, finally, let's take a look at some key points to keep in mind. The new and old series of low-voltage PowerBrick modules support mixing and matching modules for up to 3 years. If the time between the purchase of the new and old batteries is no more than 3 years, they can be used long-term. 2. If long-term use is unavoidable, perform periodic balancing by fully charging each battery individually. 3. Continuously monitor voltage, current, and temperature through the BMS system. 4. Keep the operating SOC range between 20% and 90% to reduce imbalance risks. 5. Using batteries from the same brand improves compatibility. 6. Please follow the official product manuals for detailed instructions.
That's the complete guide to mixing parallel operation for PowerBrick systems. Proper setup is key to ensuring safe and stable system performance. For further assistance, please contact Dyness support. Thanks for watching this troubleshooting video. Follow Dyness for your energy future.